Stanford University.
Okay, welcome to lecture number 13 of CS193P. Today we are going to talk about a very important topic, which is blocks. Okay, blocks is a language feature. It can be somewhat daunting syntax, especially if you're not used to things like C function pointers, because the syntax looks similar to that. But super important mechanism that a lot of iOS uses, and also that supports another important thing we're going to talk about today, which is multi-threading. Now, you've already seen with your assignments number 5 and 6, that it's great, you got this nice Flickr download happening, but your user interface feels really kind of clunky because you're always blocked waiting for this Flickr thing to come back, and so it's not responsive and the user can't click around. Once they click on a photo, they're kind of committed to that photo arriving and being displayed before they can go do something else. And so really you need multi-threading to eliminate that problem, and so we're going to talk today about how you do that, and your assignment this week is essentially going to be to make your Places app be multi-threaded. Okay? So pay close attention. All right, so let's talk about blocks. So what is a block? Now, I put bright green in there when I'm talking about a block being this language feature that I'm talking about today, versus the word block, like you want your Flickr fetch not to block your main thread. That's using the word block as a verb. Okay, here I'm talking about block, the language feature. And so on all these slides, if I'm talking about block, the language feature, I put it in green, just so you get that differentiation. So what is a block? All right, a block is a block of code, all right, meaning a sequence of lines of codes inside a curly brace. Okay, that's essentially what a block is. But when we talk about block, green block, we're talking about some mechanism and some syntax in the language that supports including these blocks of code in line, right in the middle of other code, even though you might be passing those blocks off to other methods to execute. Okay? So normally you have blocks of code, you're executing them all the time, you put an if statement, you got a block of code. But you're not usually taking a block of code and passing it off to another method and saying, hey, here's a block of code, go execute it under some circumstances. But that's exactly what we're going to do today. And what makes this into a language feature is things you have to be smart about, things like local variables that are defined before the block. And then the block starts using those local variables. What's the meaning of that, and how does that get managed? And we're going to talk about how that all works. So let's take a look, an example of using a block, so you can kind of fix in your mind what does this language feature look like. So here is a method. This is an actual method in NS Dictionary. It's called enumerate keys and objects using block. It takes only one argument, and that one argument is a block. Okay? Now you can see right away it kind of has this goofy notation where it's got the little caret. You see the caret right after the name of the method? That's the magic character for blocks, that caret. When you see that caret, that means you're doing blocks. And then it has optional arguments there. In this case, this block actually takes 3 different arguments: a key, a value, and a pointer to a Boolean, stop. And then it's just open curly brace and some lines of code. And then close curly brace. Now, these lines, so what does this method do? What's its function? It essentially executes this block that you pass as an argument every time for each key and value in the dictionary. Okay? So it's going to, this method, you send it to a dictionary. The dictionary is going to go through all its keys and values and execute this block of code for each one. Okay? So that's pretty cool. But it gets cooler because the context of this block is the scoping of the variables and stuff is the method or code that you're calling this method from. Okay? And you're going to see what that allows you to do in a moment. So I have an implementation of it here, very straightforward. It just logs the value and key that was passed. And it also looks for a key called enough, all caps. And if it sees that key, then it stops. Okay? By doing star stop equals yes. You see that third argument to our block, which is a pointer to a Boolean? I'm just going to dereference that pointer and put a yes in there. If I don't touch stop, it's just going to keep on calling, executing this block with each key and value. Okay? Question? Oh yeah, I'm missing a square bracket. Yeah, that's a good call. So see the last curly brace? There should be a square bracket semicolon after that. Sorry about that. Yeah, that's copy and paste error from the code. So yeah, so that's so the closed square bracket will be the end of the method. Yeah.
Why does
didn't stop the enumeration?
That's just how this method, enumerate keys and objects using block, defines the use of its block, right? It passes you this pointer to Boolean, and it just says, if you want to stop me executing this block, dereference this stop thing and make it yes. So that's just how it defines it, okay? It could have other ways of doing that, but that's the way it decides to do it, okay? Okay, so yeah, the caret is the key. When you see that caret, that's the magical character that means an inlined block here. Okay, so let's talk about the environment in which a method like this would be called. Okay, because you're going to call it in some other code, a method in some other object or whatever. And you might have local variables defined in your method that you can actually use inside the block. So for example, here I have a local variable called stop value, which is a double. And I've changed my implementation of my block to stop not just if enough is the key, but also if the value's double value is stop value, my local variable. So you see how I've used a local variable in a block of code that I'm passing off to someone else? Okay, absorb that for a moment. Kind of important mechanism here, because the blocks wouldn't actually be that useful if you couldn't do stuff like this. Okay, set up some local variables and then pass them through. But notice that these local variables are read-only. Okay, so here I've created yet another local variable. This one's called stopped early, which is a bool. And what I want is, if I stop early, either because of enough or because the value's double value is stop value, then I want to set a local variable to let myself know, oh, I stopped early. Okay, but I can't do this. Okay, this is illegal, and that's because all local variables like stopped early and stop value are read-only. They're essentially copied at the beginning of the block's execution, right? Whatever the value is when you pass this block off to this other method, it copies all the local variables that are needed, and they're read-only. Okay, so you can't change them unless you put this magic keyword underbar block in front of it. Okay, now this is really kind of freaky, and you want to be careful with this, and I almost recommend trying to design your code so you don't need underbar block. The reason for that, and by the way, all that does is it makes it so that that local variable can be changed. And not only can it be changed, once it's changed, when the block is finished being used by enumerate keys and objects using block, you can look at it. Okay, so its value gets changed in the outer scope too, as well as inside the block. Now you might think this is really, really useful, but one thing you have to be a little careful of is that that block you pass may not be executed right away. Okay, because you're passing that block off to the method dictionary. In this case, it is going to be executed right away because that's the semantics of this method. But I'm going to show you in the next slide or two a situation where you're going to pass a block off to an object as a method argument, and it's not going to execute it until sometime later. And so this code, if stopped early, wouldn't work because the block hasn't even been executed by the time the thing returns. So we'll see how that works. So underbar block. Be careful, it's there. You can use it, but be careful with that one. There's another way that you can have variables changed inside your block and have them affected, which is if they're an instance variable. Okay, so if stopped early was an instance variable, I wouldn't need underbar block. When my block changed it, it would change it in my object. Question?
So if you pass a pointer into a block, is the pointer read-only, or is the value the other end?
Yeah, so the question is, if I pass a pointer, either to pointer to an object or a pointer to some data structure, into my block, is the pointer read-only, or is the thing that it points to read-only? And the answer is the pointer is read-only. So you couldn't change that pointer to point to something else, but whatever it points to is accessed by reference, essentially. And that's why instance variables work. Because instance variables really like passing self into that block and then dereferencing to get at the instance variables that are stored in that object. So instance variables work to return, to get information back out of the block, but only because they're kind of a special case of passing a pointer, specifically a pointer to an object. And so let's talk more about what happens if you use a pointer inside your block. Okay, if you use a pointer to an object specifically inside your block. So here's a pointer, stop key. So instead of having enough be a literal in there. I've changed it now so I have a local variable stop key, which is an NS string, and I create it by taking enough, which is capitalized enough, and doing uppercase string, which makes it all uppercase. Now, I'm just doing that to make you realize that stop key contains an auto-release string, right? Because we know that uppercase string is a method. It doesn't have new or alloc or copy in it, so it returns something that's auto-released. So I've got this auto-released object, stop key, and I'm using it inside my block. Now, what's important to understand is that that object, stop key, gets automatically retained for you. Okay? So a retain gets sent to it. And well, now, why does that matter? Why do we need stop key to be retained? You might say, well, this block executes and the function's not over yet and it comes back out the other side. Everything should be fine. But it's not fine, and you'll see why in a moment. And also, so when does stop key finally get released? If it gets retained at the start of the block's execution, or even before that, if it gets retained, when does it actually get released? And the answer is it gets released when this block kind of goes out of scope. In other words, it can't be executed anymore, or if the block gets released, the block itself. So the block kind of acts like an object, right? It's an argument we're passing, and it is kind of a pointer to a thing on the heap. So let's talk a lot more in detail what I'm talking about here, about this retaining and releasing and all that. So we're going to use, as an example here, taking our calculator brain. We're going to go back to calculator brain. I know some of you would rather forget, okay, but we're going to go back to the calculator brain. And let's imagine that we added a method to the calculator brain called add unary operation. Takes a string, which is the name of the operation, so that'd be like square root or something like that, which executes block, and then we're going to pass it a block. Okay? Everyone understand what this method is going to do? We're going to basically tell our calculator brain, here's a new kind of operation that you're going to support. It's called operation, the first argument. And when that operation gets executed, when perform operation gets called with that operation, please execute the following block of code. And then we're going to pass it a block. Okay? Now don't worry for a moment how we declare a method that takes a block, like enumerate the keys and objects, values, whatever, took a block. I'm going to show you that in a minute. But for now, just suspend your disbelief and imagine that we can write this method that takes a string and a block of code and just associates them, okay? So notice that in this case, the block we pass won't be executed until much later, sometime undetermined in the future, when someone presses that, you know, presses a button in the UI or something that executes that operation. We are not going to talk about how you would build a UI, but you can imagine building a UI and you set the button title to be that operation. Now you have a button that can execute this operation. But this block is going to be executed at some other time. So now you can already start to see a little bit, oh, well, if this block has local variables that are objects, I better retain them at least long enough so that I can execute that block when someone presses on the button. So here's an example call of this, okay? So I still haven't shown you the definition of it, but let's just imagine someone calling it. So let's say I have NS number secret, which is an NS number, auto-released number with double, 42.0, okay? And then I'm going to call brain, add unary operation. I'm going to call this operation Multituae. That's short for meaning of life, the universe, and everything. And it executes a block, and then I just give it the block right there. Okay, the block takes a double as an operand, it returns a double, and I'm just going to return operand times our secret double value. Okay, now that block, that line of code, return operand times secret double value, that's not going to get executed right now. That's not going to get executed until later when someone performs operation, calls perform operation with Multituae, right? When they call perform operation with that, it's going to execute this block of code. So we better have secret staying around till then. That's why secret gets retained. Okay? So how would we define this magic method, add unary operation? Well, to understand that, let's talk a little bit about how we define variables whose values are blocks. Okay? Because I mean, I have variables whose values are ints. I have variables whose values are floats. I have variables whose values are pointers to objects. Right? Now I'm going to talk about creating a variable whose value is a block. Okay, everyone okay with that? So usually when we do this, we type def. I don't know if everyone knows what type def is. It's a C thing. Basically, you can define a type. So we're going to define a type, And that type is going to be a type of a variable that holds a block. And here's the syntax for that. Again, if you know about C function pointers, this doesn't look that weird. But here I've type-defed a variable called unary underbar operation underbar t. Usually when we type-def a type, we have underbar t at the end of it so that we know it's a type. So that's the name of this type-def. And the type of thing it is a pointer or a block, the little caret, you see, a block that takes a double as an operand and returns a double. Okay? So that's what unary operation t is. It is a type for a variable that holds a block that takes a double and returns a double. Okay? So now that we have that type, we could define a variable with that type. So I'm going to define a variable called square, which is of type unary underbar operation t. You see where I did that there? And then I'm going to assign a value to square. And how do I assign a value to a variable that holds a block? Well, I'm going to say it equals a block, right? Equals caret, double operand, open curly brace, the code, close curly brace. So this particular block, squares the operand, operand times operand. Yeah?
Variables like integer or double, are those copied into the block? If say your block refers to something that's a constant, not a constant, but another...
A primitive type, you mean? Yeah, so the question is, what if my block refers to a primitive type, like an int or a float or something like that? And the answer is, it is copied, read-only. Okay, at the beginning, whatever the value is, the beginning, it's copied. Unless you have that underbar block, then that primitive can be changed inside the block, and when the block comes out, when the code is done executing, that variable will be changed back in whatever scope it was defined. Okay, so that's the answer. Okay, so here I've defined a variable of type unary operation t. I've assigned it a value. How would I actually use it? Okay, how do I actually execute that block? And the answer is it looks just like a function call. You see I have double square of 5 equals square, which is a variable, parentheses, the arguments. In this case, it takes a double, 5.0, and you can see that it returns a double as well. Okay? So I know this is kind of weird, having variables whose value is blocks, and then we're executing them. It looks like a function call, but that's the syntax. And it actually makes a lot of sense when you know about C and when you see how we use it to implement things. It's going to actually be quite sensible. But the magic character, of course, is the caret. When you see that caret, that means I'm going to define the value of a block here. Now, we don't have to type def. I showed you type defing here. You don't have to type def. Down at the bottom here is what the syntax would look like if I just wanted to declare square and assign it a value without creating a type def unary underbar operation underbar t. Okay? Looks very similar. You don't have the word type def. In the place where the type def type's name would be, you actually have the variable name, etc. So you can stare at that later if you want. But that's it. So now, so we had a little aside here where we've talked about how to declare a variable whose type, a type of variable whose value is a block. So now it should be easy for us to go back to our method we're trying to create, because it takes an argument, which is a block, and now we have a type for it, unary operation underbar t. So here's what the definition of add unary operation, which executes block, would look like. It just takes an argument, unary operation t, op block. Okay? So that's how we've declared that that's the variable it's going to take as a block. And so we'll obviously have to have defined that type def before. That's why I put it there. But it's the same thing on the previous page. And let's look at the implementation of this. Really simple implementation. I'm just going to have an instance variable in my calculator brain, which is operation dictionary. It's just going to be a normal NS mutable dictionary. And its keys are going to be the operations, like square root, SQRT, or MOTLUAE. Those are going to be the keys. And the values are going to be blocks. Now, notice I've treated op block like an object here. Okay, because it's a mutable dictionary. I threw it in there like it was an object. And blocks, for the purposes of Objective-C, they act a lot like objects, but really the only messages you're ever going to send a block would be copy, retain, release, or auto-release. In other words, memory management. Okay? And in fact, when I execute this line of code, operation dictionary set object op block for key, it's going to send retain to that op block because that's what dictionaries do. When you put something in them, they send retain to it. Everyone got that? Now, of course, when I pull this out, if I were to remove that thing from the dictionary, remove that key, then that op block would get released. Okay? And that's when you can imagine things like those local variables that got retained, like secret, they would also be released then. Do you see? So when I say the op block, that variables that come in, pointers that come into the op block get retained until the block gets released, now you can imagine when the block would get released, right? When it gets pulled out. Or if this NS dictionary here, operation dictionary, itself got released, because when a dictionary is released, it releases all its keys and values. And one of the values, or the values in this thing, are all op blocks, they would all get released. So any variables like secret that were auto-released and got retained, they would go back to being auto-released and they get released. Okay? So if we had this method, add unary operation, then how would we use it? Okay, well, of course, we would go down to perform operation in our calculator brain, which is a method you're very familiar with. It's the thing that says if operation equals square root, then do this. Else if operation equals plus minus, then do this. Well, probably at the top of the method, we would say unary operation t unary op equals operation dictionary, object for key, operation. Okay, we're being asked to perform an operation. We're going to look in our operation dictionary, and we're going to find out if we got a block for that thing. And if we do, we assign it to this variable unary op, which is of type unary operation t. Okay? If we found something out of the dictionary, then we call it just by saying self.operand equals unary op self.operand. Right? This is inside calculator brain, so its operand is the operand. And we get the value back from executing that block, and that's our new operand. Okay? Everybody got that? I see some nodding heads, but I also see some, Okay, so going back to the calling of it, so here's secret, it's kind of dimmed out, sorry about that. But so here we had secret, it was a number 42, and we said add unary operation, right, the operation name and the block, defined what the block is. So if we were to have called this, then if we called perform operation MOLTUAE, then it would execute this block of code, and secret, which is 42, okay, would be fine because it got retained. Okay, so it stays around and it would execute this code and return 42 times the operand. Okay? So hopefully this example will help you understand what I mean by the retaining of objects that go in there, and that the op blocks kind of are like objects. They act very much like objects, at least from a memory management point of view. Now, as you might expect, if you access an instance variable inside your block, then self will be retained. Okay? That's because your object might call add unary operation, then someone might just release your object. But your object still needs to be around if this block wants to use an instance variable, so it'll get retained by this block. Okay? If all this kind of you're a little shaky, like what's really going on, the key thing to note is it does the right thing 95% of the time. It does exactly what you would expect it to do most of the time. Okay? And that makes it really easy to write code. So let's go back now to looking at blocks as arguments to methods. A lot of times if you have a block which is an argument to a method and the object is not going to keep it around, like add unary operation did, so for example, like enumerate keys and objects using block, it's going to execute that block right in there. Usually they won't create a type def. So this is, if you look at the documentation for enumerate keys and objects using block, this is what it looks like. Now, I just want to make sure you understand the syntax here. It looks just like the type def with the name of the type def not there, because we're not defining a type def, we're just specifying the type of an argument. So you can see that the caret, you see how it's in a parentheses by itself as the argument to this method? That's normally where like the name of the type def or the name of a variable would be. So it's just not there. Otherwise, it looks the same. Okay? All right. Okay. Now, when you're defining a block, when you're calling a method that takes a block, you get to use a little bit of shorthand. For example, if the block takes no arguments, then you don't have to put open parentheses, close parentheses as the arguments. You can just put caret, open curly brace. Okay, and that's quite common. Also, you'd never have to define the return type when you're calling the thing. So you notice here, when we're calling add unary operation, and we say caret, double operand, because we're going to have a block here, we don't say double caret double operand. In other words, we don't specify the return value. The return value can be implied by the compiler from whatever you return out of the block. Okay? The compiler will type check that against the thing you're passing it to. Here's another example of a block being called. This block, this passed to animation with duration, takes no arguments, and it returns no arguments. And so it's just caret, open curly brace, the code, close curly brace. Right? No parentheses at all in that one. Okay? All right, so that's the syntax. You know, it's kind of might be a little hard to understand, but if you stare at it after a while and after you see it used, which I'm going to do it in a demo today, it'll start to become more comfortable with it. All right, so when do we use these blocks in iOS? All right, you already saw on a previous slide we use it for enumeration. Okay, so there are block methods on NSArray and NSDictionary, even NSString. You can say to NSString, like let's say you had a big NSString that was a file that you loaded in, read it from a file, and it had a bunch of lines. There's an NSString method that says enumerate all the lines of this big string object one by one and call this block for each line. So the argument would be an NSString with that line from the file. Okay. View animations, you saw that as the last example I used on the previous slide. We're going to talk about view animations in a future lecture. That's a mechanism for animating the opacity and the affine transform of a view. That stuff is all done with blocks, and we'll talk about how that's done. Sorting, we've already seen where we specify a selector for sorting. Like when we're doing a fetch results controller, we'll specify here's a selector. You can imagine you have methods that do sorting that instead of specifying selector to compare objects, it just says sort using this block. And the block takes two arguments, which is the two objects to compare, and it returns an NS comparison result, which is it's ordered the same, ordered greater than, ordered less than. So you can imagine using blocks there. Notification is a common one. We talked about notification actually way back in the very first lecture. It's kind of the radio station way of having objects communicate. We will be talking about that in a future lecture. But you can imagine there, you could register for a notification where the radio station, when it broadcasts, executes a block. Okay, a block is provided by some object. It doesn't know who, but somebody registers to receive a notification and gives you a block, and it executes it when that notification happens. Same thing, error handlers, easy to imagine that. Incompletion handlers too. So do this thing, and when you're done, execute this block. Okay, because this thing I'm asking you to do might take a while. All right, so that's using blocks. The most important, well, not the most important, but a very important use of blocks, however, is multithreading. Okay, so I didn't show you all that block stuff for nothing when it comes to multithreading. We're going to do our multithreading by essentially queuing blocks up to execute in other threads. Okay, that's fundamentally how we're going to do multithreading. So let's talk about the multithreading. The multithreading is done with an API. It's a C API called Grand Central Dispatch. Okay, which is hard to say, but easier than NS Fetched Results Controller, which I had to say 5 times fast to prepare for this lecture, but should have done it for last lecture. Anyway, Grand Central Dispatch, it's a C API for multithreading. Okay? The idea is that you're going to queue up blocks to execute on other threads. And by queue up, I mean queue like you're going to get in a queue or a computer science queue. A queue means you put things in there, and the first things that go in are the first things that come out. But you can put a lot of things on the list. And so you're going to create this long queue, or short queue, of blocks. And the system is going to grab those blocks off of the queue and execute them in another thread. It's as simple as that. Now, that provides, and it turns out, an enormous amount of power, and it makes your code really understandable and easy to write, and you're going to see that as well. There are some queues, global queues in the system, that when you put a block in there, it could execute at any time. Okay? It's almost like it's not really a queue because everything on the queue can be pulled off and run concurrently, all at the same time, okay, in multiple threads. We're not going to talk about those today. We're going to talk about serial queues, which are you put the blocks on the queue and it executes them one at a time in order, right, serially, one at a time. It can't grab them all off and start them all running at the same time. So that's serial queues. That's what we're going to talk about today. But the multiple queues is similar. It's just that there's these global queues which run with a certain priority, and you get the global queue and work on that. But serial queues, you usually create them, although there are some serial queues that are special, like the main queue, right, which is where all your user interface code runs. And we'll talk about how to deal with that. So, yeah, so the system runs these operations from the queues in separate threads. Why is that a good thing? Well, obviously, if you had a multiprocessor, that'd be great, okay? Because it would be running these things in different threads. It'd be using different processors. Even a multi-core processor would be great for this because it could queue up multiple things to run. But really, on the iPhone, what's really great about it is when a queue blocks, other queues still run. Okay? So now imagine your Flickr app, and you've got a queue which is doing Flickr downloads, and it blocks, waiting for Flickr to respond. Your main thread is still running, still taking touch events, all that stuff. And that's the advantage here of threading here. Okay? And that's a big advantage, to have it so that you can fork off these blocks that run in other threads, and if they block, not green block, but block like stop, then they're not stopping the other queues. The other queues keep on running. So you get this nice responsive user interface, and you can still fork off things that are blocking. All right, so how do we use this to our advantage? Obviously, it's obvious how to do it in places. Also, we could use it to do time-consuming activity concurrently. So our main thread, we never want it to block, but it sits idle a lot too, because the user is just staring at their phone, they're not doing anything. That main queue is not doing anything, so you'd like to have other queues off doing some intensive operation if you had some big amount of work to do, right? So you can imagine both those things would be valuable. All right, so what are the important functions in this C API? There's about 20 functions, maybe even more than that, maybe 25 functions, but these 5 are the ones that are most important to you and that kind of introductory level to how to use these things and that you'll need for your homework. So the first pair there are creating and releasing queues. It's very easy to create a queue. You just call dispatch queue create. It really only takes one argument. It takes 2, but the second one for now is always null. But the first argument is a const char star, not an NS string, const char star. Okay? And that's just a label that's used, for example, in the debugger or the other performance tools to name your queue. Okay? Because you got this queue, it's executing these blocks, you want to look at it in the debugger, you want to be able to recognize it. And so this is just a name. You can give it any name you want. All right? It's nice to give each one its own name so that you can differentiate them if you're in the debugger. And then release, you have to release them. Okay, because obviously creating it, allocating memory for it, when you're done with it, you have to release. Now, the thing about releasing a queue, though, is you can release a queue that you created, but it's not going to actually go away until the queue is empty. Okay? Until all the blocks have been taken off the queue and executed. So usually the way we do this is we create a queue, we throw a block onto the queue, and then we release it. And then later, when the block finally runs, which could be any time in the future, and the queue gets empty, then it'll actually get released. Okay? So the second important method here is putting blocks in the queue. Very simple also. Dispatch async. There's also dispatch sync. Dispatch async takes a queue and a block, all those things we've been talking about, and puts that block on the queue. And immediately, it returns immediately, basically, back to the calling code. Yeah? The question is, can you pass a function? And there's a different Grand Central Dispatch method called dispatch underbar async underbar f, I believe. And it takes a function instead of a block. So the answer is yes, but almost no one ever does that. Okay, we use blocks. It's much nicer code. So the dispatch sync, which I haven't put up here, which you're probably not going to use, that would block the thread that's calling this until the thread that is executing that block gets to run and completes running that block. Okay? Now, obviously, you would never call dispatch sync from the main thread because you never want the main thread to block. But you could imagine calling dispatch sync from other threads that might depend on each other, etc. But for this course, we're going to focus on dispatch async, which returns immediately. It just puts that block on that queue that you specified, and returns immediately. And then sometime later, that block is going to be picked up off that queue and run in another thread. You don't know when. It might happen really quickly. Might not happen for an eternity, like a few milliseconds. Okay, that's a long, long time. You can computer brain. And then the last couple here are getting a couple of interesting queues. One is the current queue. So that's the queue that this code is running on. Okay, the code that's calling this function, dispatch get current queue. What queue is it running in? Is it running in the main queue, or is it running in some other queue, whatever? So it returns that queue, and I'll show you in the demo why you might want to know that. And then there's also the very important get main queue. Okay, and you need the main queue, for example, if you want to execute a block that does anything with UIKit, almost anything. All right, so if you're going to set some value in a scroll bar, scroll view, or UI button title, or anything like that, you have to execute that block in the main queue. Okay, you cannot execute it in another queue. It's not thread safe. Okay. All right. So, what does it look like to call these? So here's view will appear. You probably have a view will appear that's close to this. Might have a couple extra more lines of code in there, but this is the basic idea, right? You fetch your image data for your photo. So I'm assuming that photo here is an instance variable that has, let's say a subclass of NSManage object, okay, which is a photo. And it's got a method called URL, which returns the string, which is the URL for the image for this photo. So here I'm getting the image data by calling image data for photo with URL string and Flickr fetcher. That's going to block. That's bad. Then when I have the data, I create a UI image, set it as the image view's image, reset the image view's frame to match it, and then set the content size of my scroll view to match as well. And voila. Now, I'm doing this every time in view will appear, which may not be super efficient, but maybe not. But anyway, the bad thing, though, is that this blocks. So every time this view is about to appear, it blocks for a second or so while it goes to Flickr. And so we want to fix that. All right, so how do we fix that? All right, so we're going to take this block of code that we want to execute, and we're going to execute it in a different thread. Okay, so here's how we create the other thread. I'm going to call it download queue. I just say dispatch queue create. I'm going to give the name Flickr downloader to the name of this queue. So if I looked in the debugger, that's what it would be called, and I pass null as the second argument. And then I just do dispatch async to the queue a block, which is that block of code I want executed. It's as simple as that. So now you see how the combination of the blocks syntax, simple syntax, and how it can you can inline the block makes it so that your code changes very little when you want to fork off a thread to do something. Okay? Now this is not good. Okay, this code, we're not done yet because it has a problem. I told you only that UIKit code can only be executed in the main thread. But here I'm forking off this thing to download queue. That's a different queue than the main queue. And I'm calling self.imageview.image and self.imageview.frame, self.scrollview.content-size as bad. Okay, don't want to do that. Okay, because that's not the main thread. So how do we fix that? Well, let's just take that block of code and let's execute that in the main thread. Okay? So is this okay to do? And the answer is yeah. This is exactly how you mix the threads, where you have one thread created that does the Flickr fetcher, and then that thread is asking back to the main thread, can you please execute this block? It puts it on the main thread's queue. Right? Now the main thread might be busy at the time handling a touch event or something, but eventually it'll come back around and take the next block off of its queue, which would be this block, and go ahead and execute this. All right? So now you're starting to see the power, truly, of this inlining blocking and being able to get a hold of queues and dispatch things asynchronously so easily. All right? But this has still got a problem. Okay? NSManaged object context is not thread safe. And look what I'm doing with photo.url down there. Okay? Photo.url, that's me sending a message to an NSManaged object, photo, to get its URL string. And I'm not doing that in the main queue. Right? I'm doing that in this download queue that I created. But presumably that NSManaged object context that photo was created in, that was presumably created in the main queue. So you can only send messages to those NS-managed objects that come from that context in the main queue. So how do we fix that? Right? We've run into a bit of a conundrum here, but easily fixed by the power of blocks. We're just going to create a local variable called URL, and we're going to set it equal to photo.url, and then we're going to change the call inside that queue to just be URL. Right? And I told you that blocks retain a copy of any object that's declared locally before they execute. And so that URL is going to get retained, and it's going to live until this block actually executes, which is going to be sometime in the future. It's getting executed in a thread. We don't know when. It could be many milliseconds from now, actually, that this gets executed. But it's going to work perfectly fine. So you see here how we've used two different mechanisms to solve the problem of things not being able to be accessed in a certain thread. Right? One we did by having a thread send message back to the main queue, and another one we solved just by having a local variable at the beginning. But there's still one more problem with this, which is that this code leaks. Okay? It leaks that queue. I said dispatch queue create, and I never release it. So down at the bottom here, I need to say dispatch release, download queue. Now, dispatch async, I told you that returns immediately. But it's OK. We're not going to create the queue, call dispatch async, and then release the queue out from under it, because as soon as we did dispatch async, a block got onto that queue. And so when we release the queue, it won't actually get deallocked until all the queues, including this one we just put on with dispatch async, until they've had a chance to run, until the queue is empty. OK? So that's it. That's how we do it. So the demo that I'm going to do today is I'm going to take Shutterbug, which we worked on last time, and I'm going to add a photo view controller to it, and then we're going to make it so that it doesn't block the main thread. Now watch carefully, because this is part of, not all of, but part of your assignment that you're going to have on Thursday. You're going to have to do pretty much this exact same thing. And so that I can get out of here, I said the next homework will be assigned next Tuesday, due the following Monday. Not necessarily. I have to still decide whether we're going to do that, because Thursday lecture I'm not going to be covering corridor location and MapKit until the next lecture, and so I may or may not do that. So it's possible that your homework will be normal Thursday to Wednesday, but it might be that I assign it Tuesday and it's due the Monday after. We'll let you know. All right, so let's just go back to Shutterbug here. Yeah, I had this. Go to Shutterbug. OK. So I'm going to do this Shutterbug enhanced. Any questions before I do this demo, by the way? OK. So we're going to do Shutterbug enhanced. This is where we left it off. I'm actually going to take a second here, because we rushed this Shutterbug thing last time. There were two things that get really rushed at the ends that I just want to go over. One really quickly, which I talked about before, but this save context. Right? So when we added all these photos to our core data database, when we were rushing, we didn't have this save context. Obviously, we need that. The save context is provided for us automatically by this use core data for storage button. And all it's really doing is this save. Right? It's doing the manage object context save, catching the error and logging it. OK, so that's all that's happening there. And then the other problem thing we had when we copied and pasted was when we copied and pasted this init, right here when we had this cache, I quickly just put in another cache name there, but we can't have a cache here. And the reason this cache has to be nil is because this predicate that's used, right, that would be used to fill this cache, changes each time we create a new Photos by Photographer table view controller. And so you can't be changing the predicate out from underneath the cache. The cache is caching the result of a certain fetch. And so if you're changing the predicate, now you've got a new fetch and you need a new cache. Now we could have deleted the cache each time. There is a delete cache method. But it's, in this case, since there's a small amount of results returning anyway, we're just going to not have a cache, and that solves that problem. OK? So that's that. OK, so now I'm going to really quickly create a photo view controller, which all of you should have done in your assignment. And my photo view controller is going to be a UI view controller subclass. And I'm actually going to use a zib for mine, and you'll see why I'm going to do that. So I'm going to click here. I'm going to call it Photo View Controller. And here it is, and I'm going to move this out into my resources as usual. Let's put this up here so they're together. Okay, so my Photo View Controller, its model is going to be a photo. So I'm going to say Photo star Photo. That's its model. Better import photo. And its view is going to be a scroll view with an image view inside. Now, for time today, it's not going to be a zooming one. It's just going to be a scroll view with the image in there. You can scroll around. We won't be able to zoom. You know how to do all that. You've done all that. So I just need a scroll view, which I'm going to call scroll view, and I need a image view. Okay, I'm also going to create a property for my model. Okay, I'm going to have my properties for my IB outlets be private. So let's do that here. Interface, photo view controller, assign properties, IB outlet, retain. So we'll do UI scroll view. I'm kind of doing this, going to the time to do this just so those of you who are still kind of a little unclear on this whole how to add properties and stuff, we'll just see this happen. It's not really a lot of code, but so here I've added a private thing. I'm going to, private outlets. I'm going to synthesize them, an image view, and I'm going to synthesize my photo as well. And then let's do our memory management down here. We're just going to release our scroll view. Let's release our image view. And let's release our photo, our model. And then in this, we're going to have self.scrollView equals nil and self.imageView equals nil. Okay, so that's just standard operating procedure of creating a view controller. Now let's go over to our zip file and create that UI. So I'm just double clicking here in Interface Builder. Let's move this over, make some room here. So this is really straightforward. I'm just going to grab a scroll view. Where's my scroll view? It is right here. I'm going to put that in here. I'm going to have it fill the whole space. And then I'm going to grab an image view and have it fill the entire scroll view. Now, one thing when you're dragging views out like that, and especially if you're putting a view inside another view, there's a useful way to look at it over here in this view, which is instead of looking at it in this mode, look at it in this mode. And you can actually see the view hierarchy by clicking here. So I can see the image view is inside my scroll view, which is what I want, right? I want my image view to be a sub-view of my scroll view because the image view is going to get scrolled around. I can also use it to connect here too. So for example, I can connect this scroll view right here, and I can connect this image view right here. Okay, so that's that. The only other thing I need to do here is implement view will appear to display this, and then implement the pusher that pushes it. So let's do view will appear. So view will appear is pretty straightforward. Let's go ns data, image data equals Flickr fetcher. Better put Flickr fetcher up here. Oops. Import Flickr fetcher. And it's called, what's that thing called? Image data for photo with URL string, photo.url. Then, make sure I don't forget anything over here. Let's just create our UI image by saying UI image, image with data. And then let's make our image views image be that image. And we'll make our image views frame. This is the code we saw in the slides. So 0, 0, image.size.width, image.size.height. Sorry, this keyboard is quite different from mine. And then scroll view content size equals the image's size. Okay, So hopefully, let's see, did I type anything? I got type something wrong there. Oh, sorry, it's not called URL, it's called image URL here. Okay, so that's that, and the only thing left to do is in our photos thing, instead of just logging the photo here, I'm actually going to push. So I just need to say photo view controller PVC equals photo view controller alloc init. You can see I'm a fan of doing that PVC type thing. Probably not the best name, but photo view controller. Okay, we need to set the photo equals photo, and then self.navigation controller push PVC animated yes PVC release. Okay, so there's a quick review: view controllers, model, view, zip files, pushing, etc. So let's go and see if we made any mistakes here. Okay, so here we go. I'm using Shutterbug Enhanced, which has these sections in there, which is kind of nice. And we click on something. We have a couple photos here. We load it. We get a picture of Gabby here. And we're here's village in Laos. Pretty awesome. So this is good, but again, the problem is we're blocking our main thread, both to start and to do the photo. And this is pretty good, but you can still see there's a little bit of halting there, right there. And for example, if I did this and then go back, if it didn't load, it wouldn't, it would block. So let's go ahead and put in some threading code to make it so that we have something works a little nicer. Now, the first thing I'm going to do to make this work is when the user clicks on a photo to display it, I'm going to put up a little spinner. Instead of having a blank view, and in fact, let's do this really quickly. Watch this. Let's, yeah. So instead of having a blank view when I click on a photo and it hasn't loaded it yet, I'm going to display a little spinner. All right, so let's go back to Interface Builder, and I'm going to put that spinner in there. All right, find space for this. And there's a built-in one in UIKit. It's called Activity Indicator View. You can see it right here. I'm just going to drag it out. Put it right here. One thing I want to make sure is that it's not a subview of the scroll view, because I don't want it scrolling around. I want it to stay in the center. So I'm going to go down here and check that. And in fact, it put it as a subview of the scroll view. So I'm going to drag it out to be at the same level as the scroll view. The other thing about it is I want it to stay in the center. So I'm not going to have it hooked to an edge. All right, I'm going to stay in the center. And then the last thing I want to do is when it's not spinning, I want it to hide itself. I don't want it to be on screen when it's not spinning. And that way I can just tell it to start animating or not, and it'll spin or not. Let's also create the proper properties for it. So IB outlet UI activity indicator view, I'm going to call it spinner. And since we are running short on time, I won't create a property for it, but you know how to do that, just like we do the other things. So let's go back here. Let's hook it up like this, spinner, save. Okay, so now I have this spinner that's on screen, and when it's running, it's going to be up there spinning, and when it's hidden, it won't be. All right, it won't be on screen. So let's just dive right into how we would do this. Now, one thing I don't like about the way we've implemented this is we're doing this flicker fetcher fetch in photo view controller. Okay, photo view controller's model is a photo. Really, we should be getting that image data from that photo object, right? So I could go over to photo. For example, I could make a method nsData image data, okay, and it would return the image data, and it could do the flicker fetch. All right, and that would probably be cleaner code. So I wouldn't, because this image data really belongs to this photo object. It's not part of this photo view controller. But there's a problem with this API right here. If I do image data, the problem is that thing wants to fork off a thread to get that image data. And what's it going to return to me here? It's going to have to just return nil. Now, the next time I call it, maybe that thread has run and it won't return nil. But there's nothing I can do here to return the image data unless I'm going to block. And I don't want to block. Does everyone see the problem? Okay? So this is where API design comes into place. So really we need a different kind of API here to do this instead of just give me the image data. And so I'm going to propose this API. So you're going to watch this. So I'm going to say, I'm going to have void, and I'm going to say process image data with block. So I'm going to have people who want to get the image data for a photo send this message, process image data with block, and they're going to have to provide the photo object with a block of code to run when the image data comes back. You see? So I'm kind of doing this intentionally because I want to show you what it's like to write a method that takes a block as an argument, but it's also probably good API. It's certainly better API than having image data, which can't really do its job in another thread. So how would we define the argument to this block? Well, as with any object or any argument, it needs a name. I'm going to call this thing, we'll call it block. It doesn't really matter what we call the variable. Maybe might be better to call it something like process image or something like that, because that's really what this block does. It processes the image data that comes back. Process image data, maybe you could call it. Now, this thing is going to return void because I'm just going to give it the image data and it's going to process it, and that's it. It's not going to return any value or anything like that. I got to have my magic caret in there, right? This thing does take an argument, though, this block, which is the image data. I'm going to hand it the image data. So I'm just going to say nsdata star image data. Okay? And that's it. So that's the syntax we need to define a block that someone's going to pass to us that takes an image data as an argument, doesn't return anything. And so let's go implement this. Okay, I'm just going to copy and paste this declaration into the implementation. Okay, so how does this work to implement this? Well, the most important part of this thing is we obviously want to create another queue to download this thing from Flickr, right? So let's just start right off with that. So I'm going to have a dispatch queue. This is the type of a dispatch queue. I'm going to call it download queue, and it's going to be dispatch queue create. And I'm going to call this Flickr downloader in photo. That way I'll know it's, in case there's a Flickr downloader somewhere else, this is the one in photo, and we pass null as that argument as always. Now, what do we need to do inside of this queue? Well, we just need to do that Flickr fetch, and when we get the data back, we're going to call this block that the user provided for us. So we just say dispatch async, dispatch underbar async. And the queue is the download queue. And the block is going to be the following. Oops. All right, no L. OK. So the block is just going to get that data from Flickr, right? Image data from Flickr fetcher. Image data for photo with URL string. And this is self.url string. What is it? Image URL. Self.image URL. And then we're just going to execute that block. Okay? Now, that block that we execute, we could just say process image data. Right? So this would actually be fine. Is there any problem with this? Yeah. Does the block retain self? Yes. Because we're accessing an instance variable here in self.image URL, self is just like any other object, like secret was. It will get retained and released later. So there's two problems with this, by the way. One is we need to do dispatch release, okay, because we don't want to leak that queue, but that's a minor problem. The bigger problem is the context in which we're calling process image. Okay, process image is a block given to us by anybody. Could be anybody. All right, we want to make sure when we execute their block, we execute it in the same queue as they called us. Do you see why? Because that block might have NS-managed objects being accessed in there. It might have UI in there. We got to make sure it's in the right thread. Now, we could just execute it on the main queue, but that wouldn't be right either. because maybe this caller is calling us from another thread, not the main queue, and he has his own NS-managed object context, and he doesn't have any UI code in there. So he's just providing us a block. But we do need to execute this in the caller's queue. And so here's how we do that. We're just going to create a variable here, dispatch queue. And this is going to be the caller's queue. And we get that with the the sheet function I talked about called getCurrentQueue. Okay? So that's going to get the queue that is executing this method, processImageData with block. And then down here, instead of just calling processImage, I'm going to say dispatch async to the caller's queue a block which does processImage. Okay, everyone understand why I did that? I want to make sure that processImage, which was the block that was passed to us, gets executed in the same queue as the person who's calling this method. Okay? Again, I see some nodding heads, but I see some like, not sure about that. So if we have this method then, let's go back to photo view controller. How would we implement this? And the answer, very straightforward. I'm just going to say self.photo basically. Process image data with block, and I'm just going to provide the block right here. Sorry, ns data star image data. Okay, I'm just going to do this. Okay, and we don't need this anymore. That's it. So now you can see why I want to execute this block that I'm passing to process image data in the same queue that I'm in, because clearly in this case it's the main queue where I'm executing UI code. Yeah. Oh yeah, sorry, I always do this. The compiler catches it for me, but yeah, close square bracket. Okay. So that's it. Now one last thing I want to put in here is that spinner. All right. So where am I going to put my spinner? Well, every time view will appear, I'm going to start my spinner going. Okay, and there's a method in spinner called start animating, starts it going. And then I'm only going to stop the spinner when I've got the image data loaded up and it's in my scroll view. So that's here, spinner, stop animating. Everyone got that? How I'm doing that, spinner? Okay, so let's see if that works. We have such fast internet here at Stanford that we're hardly going to have our spinner up for seconds, but yeah, maybe not even a second. Let's find something. Hopefully we'll get a big one. There you go. So you saw the spinner there for a moment. We have very fast internet here, so it's hard to... Did you saw it come up there? Now the other interesting thing too is if I go like this and try, click on something here and click back before the thing loads, if it was taking long enough, it could actually go back. While the spinner is spinning, I can go back. And it's not blocked. I'm not blocked waiting because I'm loading that image in some other thread. Let's see. I think maybe we can, yeah. So I was hoping that there'd be some nice big photos, but too fast of internet here to really show that. There you go. So there's one. You see, I clicked over, started spinning. I clicked back. It never showed the image, right? Because it took too long, more than half a second. Question?
So if that thread returns and it gets the image, and you've already gone back, and you click on the same image again, it's a new request, right? So
correct. Right. So the question is, I click on the image, it starts that thread, starts it downloading, I click back, okay? And that thread's still running, still loading the image, but that thing's not even on screen anymore. Now I click forward again, it's going to fork off another thread to go load it, because that other one is kind of lost. It's, it's basically, when it returns, when this code returns from the one that went back, okay, this object, this photo view controller, is going to be pending release. It's going to have been released by everyone except this block. And so when this block executed, it's going to get released in dialect. Everyone got that? And in fact, for performance reasons, you might want to put something like this. If self.view.window, then put the image on. In other words, if I've gone off screen, remember we're in view will appear here. If I've gone off screen, don't even bother doing this. It's a waste of time, because I'm not even on screen. Now, if I get put back on screen, it's going to do the thing again. So this is probably not great code in terms of caching the results and all that, but again, we're doing a demo here on the fly. We're going to write so many lines of code. You could imagine being smarter about whether you already have the image or not, and not constantly loading it every time a view will appear. Okay? Any question about that? So that's all I intended to show you today about this. The key thing to get out of this demo is how we called this function, right, that took a block as an argument, and how we implemented this method that took an argument. There's one other problem with this, by the way. Let's go ahead and fix this real quick, which is this, self.imageURL. Same problem I talked about in the slides. Self is an NS-managed object. Okay? We cannot be calling methods on an NS-managed object in the other thread. So this we would want to change to URL, and we would want to have a local variable here, NS-string URL equals self.imageURL. Okay, so that way we capture, we're sending the message image URL to this NS-managed object in the same thread that we're in. We capture the object. It'll be, you know, down here inside this block. It'll be retained. Everything will be fine. Okay, that's it. The next lecture is going to be on MapKit and core location. And in the meantime, we're going to have Stanford-only people will have this thing about final project guidelines and all that stuff on Thursday. Okay, see you then.
For more, please visit us at stanford.edu.